Right, today we're going to look at torque of a couple. Yesterday we did look at moment of a force, which is defined as force times perpendicular distance from the line of action of a force to the point of moment. Basically, torque is very similar to moment, and you can see in some reference book that there's no difference between these two words. But however, in A level, you need to know the difference between these two things. Okay, so first of all, what is a couple? Not exactly a boy and girl, but example can be an example of analogy. A couple is a pair of force that has equal magnitude but opposite direction, parallel but not in line with each other. So a pair of force equal in magnitude but opposite in direction. So let's draw two forces like that. So equal in magnitude, same length, opposite in direction, and they are parallel. However, they are not in line, so they have a certain separation. You cannot draw them in the same line, and they shouldn't be applying on the same line of action. For example, this one. So this one is not a couple. This one, yes. Okay, so that's the definition of a couple. And torque of couple, on the other hand, is defined as So on the other hand, is torque of couple is defined as the product of one of the force of a couple. That means one of the forces now, because they are the same, so we just take one of them, and the perpendicular distance between the two forces. So let's say the two forces just now. Okay, each of them is 5 Newton. Okay, and they are separated by a perpendicular distance of 2 meter. Okay, so we say is force of a couple, so one of them 5 Newton, perpendicular distance 2 meter, so therefore torque is 5 times 2. The symbol is the same, like I said just now. Torque and moment, basically they are the same thing. So torque, the same symbol, tau, equals to 5 times 2. So 5 times 2 for this case is 10. So 10 Newton meter. Okay, so where can you see this quantity being described? So most of the cases, they are like machines, for example inside a car. So let me show you an example of description of torque of something. So for example, in this case, you look at the screen there. So it is a Ferrari F8 Tributo, the latest one. Let's look at the description of its power. Okay, it's 2020 F8 Tributo, and you look at the line that describes torque. So torque at RPM, this one here, torque at RPM, 568 Newton meter, 3,250 round per minute. Okay, round per minute basically is one of the meter on your car dashboard. If you know how to drive, or you open your parents' car and take a look at that. So 568 Newton meter at this RPM. Okay, so how about for MyV? As for MyV 1.5, so this line here, 140 Newton meter at 4,200 RPM. So this is 568, right? 568. This one is 140. So you can see it basically represent the power in a way, because it's about turning rotation of the wheel. So of course this value is bigger than your wheel can turn more powerful, in a more powerful way. So it is a one of the quantity that is described in terms of car engine performance. All right. So where are the places that you can see torque? Is, for example, when you want to open the cap of bottle. So what you do is you actually grip on it. So the moment you grip on it and you want to turn it or twist it, so basically you are applying uh, a couple, one here by this way, then the thumb is this way, so thumb is to here and finger is to here, so it's like they work together and produce a turning effect. Okay, so that's the torque here. All right, so other incidents is like when you have a screwdriver. I mean, when you're trying to turn a screwdriver, the same thing here. You are trying to hold it at two sides actually, but you basically grip it. So idea is the same, that you have two forces in the opposite direction. This finger will be here and the thumb will be forward, depends on whether you are unscrewing or screwing tight of a screw. Okay, so you do like that. So that's torque also of a couple. Right, so now we have example uh, related to calculation. So this box here, 500 Newton, separated by D1 and D2. So these two forces, basically they are coupled. State the moment of a couple in terms of F1, F2, D1 and D2. Then calculate the torque. So from yesterday idea, basically you have let's say you have the box like this. So 500 is, if we are taking the center O as the point of moment, so 500 is down, F2 is up, so one up one down, but they cause rotation in the same direction, so actually we can add them up. So torque is F1 times D1 plus F2 times D2. Okay, then let's try to factorize that, because F1 and F2 is the same magnitude, so we can actually do like this, is F times D1 plus D2, and D1 plus D2 actually is the perpendicular distance between the couple. So then you go back to the definition of the torque, which is one of the force times perpendicular distance between the two forces, right? That's why I say basically this is the same thing. So if you calculate that, that will be 500 times 1 meter, so it's 500 Newton meter. Okay, the same unit also. Okay, that's basically what I write just now. Okay, so another example here, a steering, 15 cm. Let's say we apply a couple of 5 Newton. So that's what you do, right? You hold a steering. When you want to turn, you basically do like this, just like twisting the cap of a couple, the cap of a bottle, and also the screwdriver just now. So you twist like that, I mean you turn like that. So one force up and one force down, that's the couple. If you apply different forces, you feel that's a bit odd, because it's like you're trying to move the steering to one side harder, but the other hand does not move, so that cannot cause rotation basically. Okay, so torque of this, you try to calculate and see. You can pause the video to figure out. 5, and then we have radius 15 cm. You can convert that into meter first. Okay, basically you need to times 2, which is 30 cm or 0.3, so 5 times 0.3. How about this? If I have 10 Newton here, and R is 15 to the center or to the pivot or to the point of moment. You can pause to calculate that. Right, basically it's 10 times 0.15. Let's say I have this applied together with the force of 10 Newton. Let's say you're driving with with one of your hand, and then your friend from the side suddenly want to pull your steering from the side like that. So will you worry or not? Because it could cause it might be able to cause your vehicle to suddenly turn to the left hand side. So applying a torque of 15 Newton in such a way, applying the force of 15 Newton with both of his hand, you do like that. So will you worry or not? Answer is of course yes, to a certain extent. Of course you worry about that, but basically if you understand the situation, this 215 Newton here, they are actually giving moment that is opposite in direction. So this force will cause rotation this way, this force will cause rotation this way. So basically it doesn't cause any net moment, so it balances, we so called. So therefore the steering actually will not rotate further using your force of compared to the use of the 10 Newton there. Okay, so that is the balance, and we don't call that a couple because they are not opposite in direction, they are in the same direction, so they balance each other in terms of the moment. Okay, so next we have another case here. You can try this. You can pause the video to try this. So the torque is 100 Newton, and then it's separated by 3 cm, so we have 100 times 3. 100 times 3, you change to meter, will be 0.03, so that will be 3 Newton meter. Okay, so very straightforward. The next one, we have this. Ruler is 0.5 in its length. It's a half meter rule. Pivot at the center. The couple is applied to the ruler in such. Find the torque that's produced by this couple. So by definition, it's supposed to be 1 of the force times perpendicular distance. So you cannot straight away use 20 times 0.5 because 0.5 is not the perpendicular distance. So we need to find the perpendicular distance, okay, which is this here. So this D. So if you look at the triangle, this triangle, you can get D by using 0.5 is opposite to the 40 degrees, so it's sine 40 degree. Then only you multiply it by 20 Newton. Okay, then you get that. Okay, so you can try this. That will be your homework for the day. Okay, send me to the Google Classroom assignment.